In our notes, we're going to be talking about rational exponents. This will be a brand new topic for us. We'll start with the index, which, just to remind you, is the little number that you see inside of the radical. And the index tells us how many numbers to group. So please cross out in each and put 2 and cross out the rest of the sentence. So if we look at example A, the square root of A is the same thing as saying the square root of A. We don't always write the 2. When there is nothing written, it is implied that the 2 is there. So these both mean the same thing. And just like we've learned, when we take the square root, we find groups of 2, and we are allowed to simplify by taking 1 out. Now we're looking at the cubed root of A. So this index tells us that we're going to be grouping into 3s. So instead of 2, now we'll be circling groups of 3s. I know that 16 can be rewritten as 2 times 2 times 2 times 2. I'm now going to circle my group, and from this group, again, only 1 comes out, and the 2 that remained stays on the inside. The last example, we would pronounce this as the 4th root of A. This tells us we're grouping things into 4s now. So again, 4th root of 16 can be broken down into 4 2s. This is a perfect group of 4. Again, only 1 is pulled out, and that is our final answer. Rational exponents are exponents that are written as fractions. So down here you're going to see that x to the m over n is the same as saying the nth root of x to the power of m. Notice that the denominator becomes the index, and the numerator of the fraction is still the exponent of the term. This can be also written in parentheses, and they mean the same thing. So let's practice converting between radical form and exponent form, and then simplifying to the integer. The first one is done for us. The square root of 9 to the first power, which is also the same as just saying the square root of 9, these are the same things, can also be written as 9 to the 1/2 power. Notice that we took the index and we made it the denominator. And the 1 became the numerator. So even though we write numbers without the power of 1, when you are converting from radical to exponential form, you need to account for the 1. We know that the square root of 9 is 3 because it is a perfect square. We're going to work backwards for this one. Our integer is 4. So I need to think of the square root of what will give me 4. Well, I know that 16 is a perfect square and would yield 4. If I wrote this in rational form or exponential form, it would be 16 to the 1/2. Again, the index becomes the denominator. The 1 that is not written is our numerator. The square root of 25 can be written as 25 to the 1/2. I know that the square root of 25 is a perfect square, and it is just 5. If we're given our exponential form, I know that the base number is the radicand in radical form. I also know that the 3 in the index, or you can also interpret it as the rational form, means we're grouping things by 3's. I know that 8 is the same as 2 times 2 times 2, which is a perfect group of 3. Therefore, our answer is just 2. In the last example, we have the fourth root of 81, which can be written as 81 to the 1/4. I know that 81 is the same as 3 times 3 times 3 times 3, because 3 times 3 is 9, and 9 times 9 is 81. This is a perfect group, again, of 4. Therefore, my final answer is just 3.